Jane Crawford here at TE Connectivity. I am here with the world's greatest living experts on antenna, Bruce Bishop. Bruce is a fellow with TE on the product engineering side. Bruce has also earned the company's Lifetime Achievement Award for his contributions to science here for TE Connectivity. So Bruce, welcome. Thank you for joining us today.
Thank you, Jane.
Let's get started. You've been a lifelong enthusiast in the antenna space. What got you started?
Well, I must have had antennas in my genes, I think, because I started making antennas and tweaking on antennas when I was 10 years old. Had a shortwave radio and just always had to make a better antenna. So by the time I was 11, I had my ham radio license, making more antennas, doing science projects on antennas, and always seeing what I could do to make a better antenna. So still today, still doing my ham radio thing every day in the morning, and now I have 2 acres of antenna farm in my backyard.
No kidding. So your neighbors must love you.
Oh, they love me. No, I'm out in the rural area now. When I was in a little congested area, it wasn't that popular, I have to admit.
So Bruce, you said that you started getting excited about antennas when you were 10. How did that guide your school choices and then the companies that you wanted to work for?
Well, it really completely guided it, as it turned out. I've worked in electronics and RF type of applications all my life. Been involved in different areas, Fourier analyzers, later laser interferometers, but for the last 3 decades it's been solid antennas. So that's why I was excited about the possibility of coming to TE about 14 years ago to start the antenna group at TE.
And now that group has grown to be well over 70 engineers in that space.
Yeah.
Can you talk a little bit about that?
Sure. So back in 2001, TE decided to get into the antenna design business. They were doing some build-to-print work, but didn't have a design capability. So our humble beginnings back in 2001, it was myself and 4 engineers in Across California, and we started to go out and try to get some antenna business. So we started with, back then, notebooks and tried to get into cell phones. Finally started growing the business. We actually did most of our production domestically right here in Rochester, New York at the time. So long story short, going from 0 back then, this year we'll ship over 500 million antennas.
And what, in those early days, Bruce, what were some of the challenges that your team faced?
Oh, well, of course, no one really knew TE Tyco at the time as an antenna builder. The challenges were that at the time we had some interesting IP, we had some good engineering, but it was just getting your foot in the door. So you can imagine the major cell phone manufacturers, laptop notebook manufacturers at the time, a little bit hesitant. So we really had to win it on our technology, and that's why I think it's been that way all along with TE and how we've grown the company. Is a lot of it's based on innovation and coming up with a better solution.
And I know that you get excited and are very proud when you can help the next generation be successful in innovation. Can you talk to me a little bit about engendering that enthusiasm in the next generation?
Oh, sure. So even right from the beginning, of course I had a little bit of experience with antennas myself, but most of the engineers that we would hire were newer, out of school, and that way we were able to train them and try to instill this innovation and really encourage them to investigate new technologies. And that's been one of the most rewarding parts of my job. I love doing that. I've always been kind of a mentor and a teacher. And like you said, we've grown from our humble beginnings to about 65 engineers with labs worldwide now. So that's been a lot of fun.
So we have some questions here that have come in through some of our viewers who are watching this Google Hangout today. One person asks, how successful is TE in producing conductive ink antennas compared to our competitors?
Oh boy, that's cutting right to the chase.
There you go.
Before we get to the conductive ink antennas, maybe we can talk about a little bit of history and how we've gotten to that point. So one of TE's strengths back in the early days was we were the first ones to do the antenna is using the MID, Molded Interconnect Device technology. So this is the technology where through two-shot molding, we can put metallization on plastics. So an antenna engineer's life has become a lot more complex over the years. Starting out in the late 80s when cell phones first appeared, it was very simple. One frequency band, a pull-out width antenna, and not much to designing an antenna. As we went into the 90s, we had more frequency bands. So instead of just operating on one frequency, multi-band antennas, still not that difficult. As we went into the mid-90s, or early 90s, TE started producing the first embedded antennas that were built inside the cell phones, and they used this MID two-shot molding process for putting metallization on these plastic antenna elements. And we were very successful at it. So now as times progress, a newer technology starting in around 2000 was LDS, laser direct structure. Another way to put metallization on plastic parts and make them function as antennas. So finally cutting back to the question at hand, our latest technology that we're developing is ink printed antennas. So by being able to print with ink on different substrates, one of the drawbacks with the other technologies is they all require plating. All this metallization gets plated on the plastics. This plating process not only is time consuming, take up to 8 hours to put this metal on there, but it's not very green. We have to process a lot of wastewater. So by ink printing, it takes away that plating process. So we've been working to optimize that. We have our own staff of chemical engineers, material engineers in our R&D, corporate R&D centers. So our focus has been on optimizing the performance of these inks, the processing methods, the application methods of these inks. So, of course, I have no idea about our competitors. All I can say is we've been very successful in making these inks conductive enough so we can use them in these applications for antennas. And not only that, but we can put it on different materials. So you can see when we get talking more about wearables applications, especially for inks, we're able to do things like where it used to take an individual antenna element inside a wearable product, we can now ink print the antennas right on the housing, get better antenna performance, save a component inside, leaving room for other components. That's a win-win situation. These conductive inks can also be used for flexible materials, like this ferrite material for an NFC antenna. And we can print on glass, which is always a nice thing to do, with the glass being part of many wearable products. And also, kind of stretching that technology, we can do transparent materials. Obviously, you can't see it. We'll call it semi-transparent. Not completely transparent, but conductivity good enough to function as an antenna and still have good transparency.
That's amazing. And I mean, when you talk about this, Bruce, your eyes light up and you have this passion for innovation. How do you help your team be innovative every day, come into work and give their best when it comes to innovation?
It doesn't take that much encouragement. It's been ingrained in our antenna team since they first started TE. And TE corporate has been so supportive of R&D and innovation and new technologies. I think TE invests more than $600 million a year in R&D. So with a company with that kind of backing, it's just fostered in all the engineers at TE.
Well, that really shines through. And it must also shine through when you're talking with a customer who's got a problem. And you can be able to say, well, if you look at it this way or that way, maybe we can come up with a solution for you. Tell me about your conversations with customers.
Yeah, it's been interesting over the years. When we do talk about new technologies and possibilities, we'd love to hear from customers, not on, we just like this solution, but here's our problem. If they can just relay the problems, maybe we can come up with a better solution. So thinking back on a specific example, using this MID technology, the metallization on plastic, traditionally it would be all individual antenna elements scattered around the periphery of the device. And of course, that's got kind of an ebb and flow. So as we went through the 2000 era, devices, smartphones especially, started getting smaller and smaller. Yet we started adding more and more frequency bands, making our job difficult, more individual antennas in each smartphone. We can have up to 5 or 6 separate antennas in a smartphone. So TE was the first company to put all of those antenna elements around on one plastic piece that actually functioned as part of the frame for the phone and had all the antennas on it. So that was an interesting way that we would solve the customer's problem rather than just offering a solution.
Right. And I know that antennas in general, so that's a great example of the cell phone industry and using multiple antennas inside of one cell phone. What other industries is your team working with today?
Oh, well, overall, we're excited about the new wearables devices in industry. Traditionally, probably half of our business is in tablets and notebooks and traditional devices like that. Another large portion of our business is in smartphones. We're very big in Wi-Fi and televisions. We're in routers and set-top boxes, any number of products. So thinking about the actual wearables markets and products, it is pretty much a new area for everyone. But I think we're one of the pioneers. We were putting antennas into a pendant cell phone device almost 8 years ago. So we've been working on these new technologies and techniques for embedding small antennas, efficient antennas, in wearable devices for a long time. And there are specific challenges for those kind of devices.
Well, just smaller and tighter and more cramped space.
That's the main challenge. Also, there's other issues to consider because all these devices have to be approved by the FCC on how much of the power from the radios gets radiated into your tissue of your body or your head or your hands. So there's challenges on these antennas, making sure they're compliant with those rules. So that can also dictate how these antennas are designed.
Right. So it sounds like you know what's possible, and you also are not inhibited by the guardrails, but you also have to make it as appropriate for industry, that's why TE is the leader in this space, because of people like you. Right?
Well, we have a bit of experience. It's always trade-offs, and as time went on, smartphones first started getting smaller and smaller, and of course it made a big headache for antenna designers. Then just when we thought we were going to get a breather, came in the tablets and the phablets. Smartphones are starting to get smaller. Larger. We finally get some breathing room, and so right after that, immediately, now it's wearables, where space is really at a premium. More and more functionality, more and more radio functions in these wearables, and it's no longer just a Bluetooth connection to your phone. We have Wi-Fi directly in these devices, so you can check from the internet. We have now cell phone enabled devices, NFC, near field communication inside devices. Just a lot more functionality. So it's a big challenge.
So there's still a lot more excitement on the horizon.
That's for sure.
Can you take me through the process of designing a wearable antenna? Talk to me a little bit about that, and let's also check on time.
How are we doing on time? As far as the design process, it's changed quite a bit over the years as well. If you think back, even 10 years ago, most of the time when we were going to design antennas, and we really only concentrate on embedded antennas for devices, most of the time we'd have some real hardware available, and we'd be able to start with little machined plastic pieces and copper tape. Antenna designers love copper tape. And we make our little antenna patterns and put it on these pieces and optimize the performance. As the years have gone on, products move so quickly now. The design cycle has shortened. The production cycles have shortened. So these days, it's not unusual that we have to do a complete antenna design in a matter of 3 or 4 months. We're in production for 6 months. We build 10 million antennas, and we're done. And we have to keep that stream going. So the design cycle now, I would say 80% of the time, starts with us working with a 3D CAD file from our customers. No longer do we have any hardware. We often don't have anything similar, even especially in the wearables case, because wearables form factors are all over the board. So we will start with a 3D file, even a concept, a sketch, a cartoon from a customer, and try to determine up front how much room, how much space do we need for those antennas. We have to use our simulation programs. We use a couple, one CST, Microwave Studio, and HFSS, and we'll actually build up that complete device, put antennas in there, do our initial optimization, and let the customer know how much chance he has of success of this antenna working well. The next big change in this whole process has been the evolution of 3D printing. So in the past, we would have to have machine parts, machine plastics, machine metal pieces out of aluminum or other materials to simulate the device. Well, now with 3D printings, we can print the plastic parts. We can print plastic parts and have them metallized, or we can actually do metal 3D printed parts of whatever material we want.
So it saves an enormous amount of time.
Oh, it's huge. It's a huge savings.
And I would guess that if you're talking to a customer on Monday, and on Tuesday you can put in his hand a prototype that you've 3D printed, that probably changes the level of collaboration with that customer.
Oh, no doubt about it. And I wish it was quite that simple.
Okay.
Fabricating the parts is usually as easy as doing it in 1 or 2 days. The antenna simulations are only as good as you can characterize all the materials. That's still a challenge these days because new materials are being used. Different LEDs, OLED screens have different properties, but it is a lot quicker time to market and time to proving up these prototypes.
That's exciting. That's exciting. So I know we have another question that's come in from online. Someone says everything and everybody will be connected, but how will we discover and choose among all these connectors?
Well, the good thing is that for us antenna designers, the important thing is being able to see all those devices out in the universe and the Internet of Things. So I'm afraid we're going to have to leave that to the software people on how to pick and choose what devices want to be recognized. Nonetheless, security is going to be a big issue. You don't want all your devices to be recognized, but all we can do is try to give you the best antenna performance so we can see them out there in the Internet of Things.
And I understand today that TE, because of your work and the work of your team, that TE is the world's second largest producer of antennas for wearables. Is that the case?
Well, we don't talk about specifics, but like I said, for the consumer market, we make about 500 million antennas a year, and we think we're in a fairly good position in that market. Yeah.
So one of the things that TE is proud of is being able to work with high school kids and get them excited about engineering. We like to say that we are the champion of engineers and the engineering spirit. How do you kind of live that in your work?
Anytime we have the opportunity to speak to high schools, to participate, TE is a big supporter of a number of programs like robotics programs for junior high and high school students, and a big contributor to enabling more engineering students in our communities. Whenever we have the chance, I'd love going out and talking to students and getting them excited about engineering. So it's certainly been an exciting life for me.
Are there any student stories that resonate with you, or that you think back and you think about that one student that really got excited about engineering?
I've had a couple of encounters like that. One was I started totally out of my area, but I started making a junior high student really think about batteries and how everything we have has batteries. And well, wouldn't it be better if we could get something that was more efficient? And do you really understand how batteries work in different environments? And how about your cell phone if you're depending on that when you're up at the skiing or snowboarding? Nobody's skiing. Snowboarding, do you know that your battery may die quicker up there than it does when you're down skateboarding at the beach? And it inspired that student to really do the research and really come up with some new ideas and actually got him involved in energy harvesting and looking at what can be done with that.
So you should be proud.
Oh, it's always fun.
You should be proud. You should be proud. We have another question that's come in. What are the challenges that need to be overcome before we see widespread wireless power transmission? Can you comment on that?
Well, sure. In wireless power transmission, it's another antenna problem, really. It happens to be a completely different frequencies, but in our wearables group at TE, we're doing extensive work on that, on wireless power transmission. It's a critical part of any kind of wearable device. You don't want to have to plug in a cable. You might not even have room to plug a cable into it. So there's chips available to help optimize this wireless charging, but the main thing is, how do you couple your device to that charger? And basically, most of this is magnetic, whether it's resonant or not, coupling between two antennas. So TE is actually doing things to optimize that process in the wireless charging in our wearables group in Menlo Park, California.
And what about, I know China is an important market for us as a company in general for TE, but how about for the antenna space? What does China look like for us?
Well, right now, we're very dependent on that. So TE has design facilities in Taiwan, in Korea, in Japan, here in the US, in the Netherlands, but also in China. We have a design center in Kunshan, and we're soon to open another design center in South China. And all of our manufacturing is done in Kunshan and Qingdao and other areas of China. So definitely a crucial area, a big area for growth. We're very involved in many companies in China. And not just for traditional smartphones in that market, but like I said, we really like doing antennas for TVs and other kind of devices. For the wearables devices, many of the designs are actually started here domestically, and most of them transfer over to China. So we're very, I think we do a good job of handing off designs that are done domestically here to our labs over in the other parts of the world.
That's so funny that you say that, because I was going to ask you, how do you, when you have a global team, you have people in China, people in Korea and Japan, how do you stay connected as a team?
Oh, it's no problem. I just never sleep, and we work 24 hours a day.
Okay, that's good.
But literally, there's so much cooperation and interaction between us in California. So my lab's in California, a small lab, mainly R&D and supporting our domestic customers. But we have complete test capabilities. We have over-the-air test chambers for doing cell phone and Wi-Fi integration and testing, passive antenna testing, measurement equipment, SAR equipment, all that. But we've replicated that around the world, but it's a critical part is handing off that technology. So if we begin a design, we're always somebody on the phone with our European counterparts in the morning, and every night, there's always communication, literally at least 5 nights a week, if not 6, and making sure these projects are going smoothly in the transition from our labs domestically to our labs over in Asia.
So electricity has eliminated geography.
Yeah, I'll have to say, I think I got my first email address 20 years ago. I thought, this may never take off. I used to using fax machines and Twix before that. I have a few gray hairs, but no, with everything connected these days, there's no hiding from it, and it's really pretty easy. Having common equipment around the world, using the same software simulation systems, and being able to transfer files, transferring CAD files, being able to 3D print antennas around the world, it's really great.
Pretty much. What is your biggest challenge in addressing some of your customer needs more recently? You have such a great wealth of experience over the last few decades. What are the customer problems today that we're trying to solve?
Well, I think it goes back to the original question of this wearables area. It took a decade to solve problems where we have to deal with 41 different LTE frequency bands for smartphones and tablets. And for that, it turned out to be antennas that were tunable. Because antennas, the bandwidth of an antenna is limited by its size. So in a smartphone, a tablet, we reached those limits. Fortunately, TE has IP going back to the year 2000 on tunable antennas. We were able to apply that and get solutions for that. So most devices now to cover all these different bands have tunable antenna solutions. Going forward in wearables, like I said, it's a whole new game again. The challenge there is we're trying to put wearable devices with metal cases, extremely limited space for antennas. People don't want that to be the big stopping point. So we're doing a lot of work in our wearables lab, again in Menlo Park, of even doing antennas woven right into fabrics for your clothing. We have fabric engineers at TE. So by combining the interaction of these antennas in the body and optimizing these kind of off-the-wall solutions, we hope to be able to have solutions for many of the things that people are considering now.
That's true, and it seems to be very ubiquitous. It's in every piece of clothing and wristwatch, etc. Where you look, it's just opportunity.
That's right. Everywhere you turn, and I'm sure we haven't thought of a tenth of the applications yet. Other than the fitness and the medical applications, but we're doing antennas and things like belts and women's handbag, putting in their handbags and things like that. There's just no end to it. So 5 years from now, I can't even imagine the wearables market. It's not just going to be watches.
Yeah, much more than that. So Bruce, last question.
Sure.
Tell everybody who makes every connection count.
Oh, TE connectivity. That's our not only, we've been talking about our technology and engineering, but our manufacturing, our automated manufacturing facilities, I think, compared to by none. Just the breadth of our products. I'm pretty limited. I'm just talking here about antennas. But with all the other things that we have for wearable devices, the spring fingers, the board-to-board connectors, board-to-flex connectors, battery connectors, there's just a myriad of products that TE can bring to the wearables market.
It's exciting to talk to you. And I did say you're the world's greatest living expert,
No,
and you are.
no,
So thanks
I doubt
for spending
that.
time with us
Well,
today.
thank you, Jane.
It was great to chat with you.